अस्सलाम वालेकुम स्टूडेंट्स। आज हम स्टैटिस्टिक्स का पेपर कर रहे हैं। क्वेश्चन नंबर 1 says a competitor in throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceeds 30 meter. The probability distribution table for x is given. Here expected value of x is given. Find the values of p and the value of r. We know the sum of all the probabilities is equal to 1. So I'm going to make equation 1. So this is 0.4 plus p plus r plus 0.15, that is equal to, this is 0.15, this is 0.15 and it is 1. So p plus r, 0.4 plus 0.15, that is equal to 5, and 1 minus this whole thing, it is giving you 0.45. It's equation number 1. And now the expected value is 1.1. Expected value of x is 1.1. So we are going to get our expected value is the product of x and the probability. You can simply say 0 multiplied by 0.4 plus 1 multiplied by p plus 2 multiplied by r plus 3 multiplied by 0.15, and the value for the expected value is 1.1. So this is 0. So here you are getting p plus 2r plus 0.45. So 1.1 minus this thing, so second equation will be p plus 2r equals 0.65. It's equation number 2. You can solve simultaneously these two equations to get the values. So if we have one equation that is p plus 2r, that is 0.65, and the next one is p plus r is equal to 0.45. If we subtract this, p cancels p, so r is 0.2. So I'm getting value for the r, that is 0.2, and for p the second value is 0.45 minus 0.2, so it is 0.25. So the value for the p is 0.25. Find the numerical value of the variance of x. So variance of x follows the formula, that is expected value of x square, expected value of x square minus expected value of x, and that is whole square. So expected value of x square will be square of x into probability, that is 0.4 plus square of x 1 square multiplied by value for the p is 0.25 plus value or square of 2, that is 2 square into 0.2 plus square of 3, that is 3 square into 0.15, and minus expected value of x is 1.1 and its square. So left side, this whole thing gives you 2.4 minus 1.1 whole square, and we are getting our 1.19 is the variance of x. So this is variance. Question number 2 says George has 5 fair-sided spinner with sides labeled 1, 2, 3, 4, 5. He spins the spinner and notes the number out on the sides on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain 5. So when the experiment is repeated until the success occurs, so it's geometric, and fewer than 7. If you want to get your probability, and that is fewer than 7, so x is less than 7, so formula says 1 minus q to the power 6, fewer than 7. So if it is 1, and the probability for the q is 4/5 and whole power 6, because if probability of P is 1 over 5 and then Q is 4 by 5. So use your calculator and your answer is 0.738 till 3 significant figures. So we are done with part 1. Part 2 says George spins the spinner at 10 times. So if it is n, now it is binomial. When n is given, the distribution is binomial. So we have our P, that is 1 over 5. We have our Q, that is 4 over 5. He obtains a 5 more than 4 times but fewer than 8. So n is 10. So we have a probability that x less than 4, which is less than 8, and this is equal to probability of x, that is equal to 5, probability of x, that is equal to 6, and probability of x, that is equal to 7. So 10C5 into probability of success is 1 over 5 to the power 5, and Q is 4 over 5, and the whole power is the difference, and then R is 6. You can say this is 10C6 into probability is 1 over 5 to the power 6, and failure is 4 over 5. 10 minus 6, the power is 4, and plus 10C7, probability is 1 over 5 to the power 7 into, that is 4 by 5, and the power is 3. So here calculate all the probabilities and you will be getting your final answer, that is 0.0327155 till 3 significant figures, or you can write it, let's 0.0327 till 3 significant figures. You are done. Use the approximations. For approximations, this is 15%. So your probability for P is 0.15 and Q must be 0.85, and n, you have n 200 components, and that is 200. N is 200, P is this thing. So get NP first. Get NP. N is 200 multiplied by 0.15, so it is giving you 30, that is greater than 5. Now get NQ, that is 200 into 0.85 is giving you 170, that is greater than 5. When it is greater than 5, we approximate. So you can write we approximate. If NP and NQ are greater than 5, then we approximate binomial. We approximate the binomial to the normal distribution. Now I can get my mu, that is NP, that is equal to 30, and you have sigma, that is NPQ, and it is 25.5 whole under root. So you can, from here you can say continuity correction before standardization. So if the probability of x, that is greater than 40, which is equal to, you can say probability of x, that is greater than 40.5, 5. If it is more than, so you can say the probability of z that is greater than 40.5 minus 30 over 25.5. So the probability will be of z that is greater than 10.5 over 25.5 whole under root. If it is greater than, then we can get this thing. If it is your binomial distribution, normal distribution curve, so my final answer is 0.0188 till 3 significant figures. Question number 4. We have to make aces on left hand side and jets on the right side. These are the aces on the left and jets on the right. We need to make the key. So on the left, first make your key. Key is 4, 16, 6 means 164 centimeter for aces and 166 for jets. So if I write 16, 17, 18, 19, so here 6, 8, 0, 4, 4, 5 and 18, 1, 1, 8, 8 and here 1 and 19, that is 0. So here you can say 4, 6, 8, 9. This is 1, 3, 4, 18, 0, 1, 2, 2. Find the median in the upper quartile. So for median, we have n plus 1 over 2th value. N is 11, so 11 plus 1 over 2. So this is 6th value, and the 6th value is 173 centimeter. This is median, and here we want to get our Q1. Q1 is 1 by 4 into 11 plus 1, that is 12. This is third value, and third value is 168. And for Q3, that is 3 by 4 of 12. This is ninth, and ninth is 181. So your IQR will be the difference of 181 minus 168, that is 13 centimeter. Give one comment of the height of the aces with the spread of the height of the jets. So you can say jets have a greater variety of heights than aces. That's it. Question number 5. Find the probability that randomly chosen member of the has less than 170. So you are supposed to get the probability when x is less than 170. It means I'm going to get my probability when z is less than 170 minus 166 divided by 10. So you want to get your probability of z, that is less than 0.4, and less than, you can get your answer, that is 0.655 up till 3 significant figures. In part 2, given that 40%, this now the probability is given, so you want to get your probability of x, that is greater than h, and it is 40%. 40% mean 0.4. This is my normal distribution curve, and here this is 0.4. Now I want to get my probability greater than 1 minus phi z. So you can say the probability of z, which is less than z1, it would be 1 minus 0.4. So this is 0.6. It is actually phi of z1. I want to get the value for the z1, so phi goes there, and now phi becomes phi inverse. So this is 0.6. So from the table you can get your value from the 0.6. It is giving you 0.253. Now apply the formula for the z. Z is x minus mu over sigma. We want to get our height. Z is 0.253, and this is actually x and h. So mu is 166 over sigma is 10. So you are getting height from this expression, that is 168.53 centimeter. So we got our height from this. In part B, the random variable x is normally distributed with mean mu and standard deviation sigma. Given that sigma is this, so if sigma is given, so you can say the probability of x, that is greater than 0, which is equal to probability of z, which is greater than 0 minus mu over sigma. So this is probability of z, that is greater than minus mu over 2 by 3 of mu. So mu cancels each other, so it will give you z, which is greater than negative 1.5. So we have our normal distribution curve, and here it is a negative 1.5. So greater than this, so we can get our probability, that is 0.93319, or you can write it till 3 significant figures, 0.933 till 3 significant figures. So this is the probability. Question number 6. So Freddy has 2 bags of marbles. Marble X, this is of a probability, the tree diagram. We have to draw tree diagram for this information. Look, if we have 2 bags, bag X, this is your bag X, and this is bag Y, this is bag Y, this is bag X. The probability of it is 1 over 2, and it is also 1 over 2. And in bag X, we need to make extend this probability further, and here it is bag, let's see, this is your bag B, and this is your bag X. So this will also be extended like this and this, and further we have this bag and literally this one, and here we are this and this. So this is 7 by 10 red, this is R for red, and this is blue, and here you have further R, and this is your blue. So R is 7 by 10 and this is 3 by 10, and here we have another blue, and here it is red, and here it is blue, so it is giving you 8 by 10, and then it would be 2 by 10. So from here we can also make, so for the red you have 4 out of 5 and it would be like 1 out of 5. So this is blue, and for red, here for red and it is blue, so it is 4 out of 5, and the probability of this like this. So at the last, this is your red is 1 and then blue is 0. So we are done with this. Find the probability that both the marbles removed from the bag are of the same color, and we got to find the probability of same color. When you have same color probability, this is 1 over 2 into 7 by 10, 7 by 10, the same color, or this same color can be 1 over 2, 3 by 10 and 2 by 10. This could also be R 1 over 2, referring to your tree diagram. This is 4 over 5. This is also 4 over 5 plus 1 over 2, 1 over 5, and in the last that is 0. So grab your calculator so you can get your probability from the first one, that is 49 over 200, second is 6 over 200, third one is 16 over 50 plus 0. So the final probability will be 119 by 200, or you can say 0.595. This is the answer of this question. Find the probability that bag Y is chosen given that the marbles removed are not both the same color. It means this is conditional probability, different color. So we can say probability of Y over different color. This is of a different color. You can say the probability of Y and different color divided by probability of different color. So first it is 1 by 2 into 4 by 5, then 1 by 5 plus 1 by 2 times 1 by 5 into 1 over 1 minus 0.595 of the different color. So here you will be getting 4 by 9, final answer of your probability. The question number 7, the last question of this Andromeda, in which no constant, different arrangements, you need to find the different arrangements and not consonants. So look, if we say this arrangement, this, and then here it is A, and then 2, 3, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here it is A, E, and then O. Number of different arrangements, that would be 4 factorial over 2 factorial into 5 factorial, and repeated one is the 2 factorial. So the final answer is 720 arrangements or 720 ways. Find the number of different arrangements of the 9 letters of the word when these are not together. When these are not together, so you can say okay, total these are not together. So final are 7 factorial over 2 factorial minus 6 factorial will give you the number of arrangements when these are not together, and its final answer is 1800. 4 letters are selected at random from the 9 letters in the word Andromeda. Find the probability. Here we are going to get our probability 1D and exactly 1A. So 1D, 1A. So it could be select 2C1 times again C1 and then 5C2, 1, 1, 2, 2 and 2, 4. So it would be 40 when 2D and 1A together. It is 2C2 times 2C1 times 5C1, that is giving you 10. So total 40 plus 10 is 50. Without restriction, total number of selections without restrictions. If there are no restrictions, then you can say it is 9C4 and it is giving you 126. So the probability is 50 over 126, that is 25 over 63. That's end of this paper.